While we were figuring out electron configuration, we can use that configuration to place us on the periodic table, but then also get an idea about the properties of that element and then the properties within similar elements within the periodic table. And so we're going to start off with this electron configuration. We've got argon 4s2 3d10 and then 4p5. And so the first question is, what element is represented by this orbital diagram? So we have electrons that are 4s2. So 4s2 would put us right down here in the fourth row. 3d10, so here's those 10 electrons that are 3d. And then 4p5, so 1, 2, 3, 4, 5. That would take us to bromine. We know that because bromine should have 5 electrons in its p orbitals. It should have 1 less than the full 6 electrons needed in the p orbitals. Which element will have chemical properties most similar to those of the element represented above? So bromine, what elements would have similar properties to bromine? Any other halogen. So fluorine would be similar, chlorine would be similar, but so would iodine or antimony. Any halogen that's in that row, because it's going to have a similar electron configuration, it's going to have a full s orbital and 5 electrons in the p orbital. Because it'll have that same configuration, it'll have similar properties. So it could be chlorine, it could be fluorine, it could be iodine, and it could be antimony. How many valence electrons does this atom have? So valence electrons are the outermost electrons that participate in a reaction and therefore help describe the reactivity of an element. And our valence electrons, we have 2 electrons here in the s orbital, and we have 5 valence electrons in the p orbitals. Add those 2 together, we're looking at a total of 7 valence electrons. When we have a full d shell, we typically do not count those as valence electrons. Those do not react in the same way that the s electrons and the p electrons do. And then looking at this orbital diagram, we're asked to find out how many unpaired electrons does this atom have. And so an electron pair is simply that, 2 electrons together in an orbital. So here we have a pair, here we have 5 pairs of electrons, here we have 2 pairs, and here we have a single electron in an orbital. And so that would mean we have simply one electron that is unpaired in this electron configuration of bromine.